Attention crew. Stand by for a call.
All right, welcome to some hazmat training minutes for St. Louis County as we're going to start making hazmat great again, going across the board this time. So my name is Kyle Sanders from Metro West.
I'm Nick Kimmel from Creve Corps.
So today we're going to look at some company training for our basic 5-gas meters. If you have the MSAs, the multi-array products, and kind of go from there, we're going to dive into what we're actually looking at with these meters, breaking down like what each gas is that we're looking at, kind of going from there. When do we use these things? How do we use these things? And just kind of diving from there as we're working through all this stuff.
Yeah.
So first one, like our products, most of your 5-gas detectors have your oxygen, LEL, CO, hydrogen sulfide, and VOCs. As we go through, we're just going to break down each one of these and like really like look in depth into these gases that we're looking at here.
All right, so the first one we're going to look at is oxygen. So basically what the oxygen measures is percent volume in the atmosphere. And you really want to pay attention to significant increases or decreases in the volume of those readings. So typically there's a little bit of a bounce when we talk about oxygen readings. So it might bounce from 20.8 to 20.9 to 21.1 or 21.0. But the thing to consider is if you have a significant drop, and even if it's a 0.8 drop, but especially if you have something as much as 1% drop, you could have something that's displacing the oxygen in the atmosphere. So to consider that, a drop in 1% oxygen could be something as big as 50,000 parts per million displacement of something that's in the air that you might not know about that's affecting those oxygen readings.
The biggest thing to remember with this is this drop 1%, most of your alarms don't actually, or the meters won't alarm until 19.5%. So you might have this drop in oxygen up to 50,000 parts per million, and your meter's not even going to alert with it. So that's one of those things. If very important to keep an eye on this. I know a lot of our calls that we go on, guys like concentrate, especially CO calls or anything with a meter, they concentrate on the LEL and the CO readings. And the oxygen is always kind of like, if it's not alarming, it's not getting your attention. So kind of like that greasy wheel gets the attention type of deal. So with this one here, like Nick mentioned, like that's something to keep an eye on. Like always just keep that in the back of your mind and pay attention. Like if this drops below 20.9, you have something significant there that's displacing that oxygen that's worth finding and starting to look into what's going on.
Exactly.
So,
and we're looking about our low and high alarms. Now every sensor on your 4-gas meter has a low and high alarm. This one specifically, oxygen deficient is defined as 19.5% or below, and oxygen enriched is considered 23.5% or above. Now, the hazards with oxygen deficiency, obviously we need oxygen to breathe and to function as human beings, but with our high alarm, it's a hazard because it could be a fire hazard. Everything's more susceptible to flame up or catch fire if it's oxygen enriched. Now, those two set points are defined by OSHA, and that's why they're 19.5 and 23.5 on most of your meters. Something to consider too, we listed the range and the resolution for each sensor. What the resolution means is that that's the lowest measure of volume or percentage in this case that the sensor is going to read. So it's going to go up in increments of 0.1% instead of 10 or 0.5 or something like that. So that's just something to be aware of, and you find that out by reading your manual like we all do.
Yeah.
So
Always read the manuals. That's how you find out all the information. So lower explosive limits. This is another one, like the most common, I think, whenever we go on these calls. Everybody's always concerned about the LEL, and they're always concerned about the CO. With the lower explosive limit, and we'll talk about here in a second, is like understanding what we're actually looking at with our lower explosive limits. I know that's a big thing that we dive into and I answer a lot of questions about. And then when Spire shows up, their meters read differently than ours do. So that's a big thing too to remember whenever we're diving into this stuff. So the 10% of the LEL reading, we've got listed over here. We can kind of explain and break down a little bit more for everybody.
yeah, so we're looking at for Ray products, and I believe MSA is the same way, but again, you have to consult your manual to check and see what your equipment reads. But if we're talking about 10% of the LEL, we're getting that reading here on our meter. What that means is 10% of the LEL of methane. So our LEL sensor is calibrated to methane. Methane's LEL is 5% all the way up to 15% is a UEL. So in this range, we're going to go boom, right? So 10% of the LEL isn't 10% by volume. If we're taking the volume of the room as 0 to 100, 10% of the lower explosive limit, so way down here. So you don't need very much to get to that 10%. So that's something to consider. If it's calibrated to something else, just know those numbers and know what you're looking at.
Yeah.
Something else, Kyle, we're talking about correction factors. This is especially important for LEL and VOCs. We're going to talk about that a little bit later with the PID measuring VOCs. But you can apply correction factors to the LEL reading. So what that means is if you're seeing something else when you're doing your metering, so if you're seeing something else other than methane, so let's say we're measuring gasoline vapors, that has a specific correction factor that's based on the manufacturer. So let's say, just for discussion's sake, this is not a real correction factor, but let's say that correction factor is 10. So if I have a reading that's telling me it's 1% LEL, correction factor is 10, what's my actual reading? So how we're going to get that is we're going to multiply our actual or reading that we're getting by the correction factor, which is 10. So 10 times 1, then our actual reading is actually 10%.
Of your LEL?
Right.
Okay.
Right.
And that's where are we going to find this stuff at? Like you said, it goes back to reading your manual, right?
Yep.
Like knowing your product. And I know me and you discussed before when we were setting a lot of this up, is some of your meters, you can go in and make these correction factors in there. So that's one of those things. Like you really need to know your meters, know what you're getting off the truck with, and how these things are set up, because that's going to help you really determine this stuff. And if I don't know how these are set up, I could get false readings and kind of go down a wormhole that I don't need to go down.
Exactly.
So other than that, is there places online? I know the Ray products, we pulled those up before that you can actually has the tables that you can see all that stuff. So
yeah, and besides that, sometimes, especially with Ray, there's called technical notes that go into depth on things like that. So just go to the internet, go to your manufacturer's website, if you have MSA or BW or whoever you have, and they'll have all that information on the website, I would think.
Once again, really important to understand all of this we're talking about, you need to know your meter.
Exactly.
And how it works and what it's actually looking for. CO, I think this is one of the most common ones we do, especially this time of year in the fall and early winter. Like we run these calls multiple times a day. So the biggest thing with this, diving in and just really consider the alternative sources on these and dive in and really understand like what we're looking for with our CO readings. Where are we going to find these CO readings in the house? When do we start metering and everything like that? The cross sensitivity on the CO readings, like what's some stuff that we can give us?
So I believe, a cross sensitivity is something that, let's say a sensor thinks it sees CO, but in Ray's case, there's like a bunch of hydrogen in the atmosphere for some reason. So we've had that from batteries cooking off, car batteries that sit on a charger, and that they give off hydrogen gas sometimes when they overcook.
Yeah.
So in that case, the CO sensor thinks it's seeing CO, but it's cross-sensitive to hydrogen, so it's going to think it's seeing CO, and it's going to give you readings, even though there might not be any CO there. So something to consider too.
That's one of those. Not every call diving into this cross sensitivity. Are you going to get CO? So like I've had these calls before where you go in and there's nothing gas in the house or in an apartment, but because they have cars parked in a garage, by fire code they have to have a CO meter. This thing's alarming, you're getting readings, and you find just something that's giving off that incomplete combustion or cross sensitivity. So that's something like always dive in and look for anything and everything that could be giving off these readings to really dive in and give somebody an answer. Like I'm not a big fan, I'm sure you aren't either, about leaving calls like, man, I really still have no clue what that was. Dive in and figure that one out, and figure out what's going on to give these readings. So something else we do a lot, I think you guys at Creve Coeur probably do the same. When we're investigating these CO calls, I pull off the detector and look too, because I call it, we revoke the man cards, and you run those calls like, oh, this thing chirped 5 or 6 times, and actually like explain to the people like, hey, it chirped this many times, it means that you need a new detector, or it means that you've got this. Like it's not necessarily CO calls, but still go through and check everything. We'll turn on the furnace and probably run the hot water if they have a gas hot water heater and furnace, just to kick those up and make sure like, hey, there's actually nothing going on, and make sure they're working properly. So we've had a lot of these calls that go in and you might get readings, and it could be like something just off with the furnace a little bit, or their stove or anything like that I have to dive in, and easy fixes, but let Spire come in and check those things out.
Yeah.
So
Spire's a good resource for these calls.
Oh yeah. Think about hookah pipes and like who knows, like people anything can cause readings. So another thing we have seen like in the county, multiple places, apartment complexes and townhomes. So I know there's been 2 or 3 actual fatality CO calls that when they've gone into this townhome that the CO alarm's going off and thought they had everything and check, like, you know what, let's check the rest of the buildings, and the apartment next door was the one that actually had the leak and had stuff pegged at the door, and that was where the fatality is. So always never take for granted that, hey, I found this, especially in big buildings or apartment complexes, townhomes, and actually do justice and search as much as you can until you can actually absolutely verify that everything's safe.
Yeah, be vigilant, get your own readings if you can. Don't trust readings that are not from your people.
No, absolutely. So hydrogen sulfide. So what are we diving in? What is the hydrogen sulfide?
So most commonly we're going to see H2S is referred to as sewer gas, and basically it gets created from the decomposition of waste. So if we're talking about a sewer, that could be things like rotting leaves, just general debris that's organic, that sits there and just keeps decomposing, rotting, and that gives off gas. So bacteria that's eating and doing all that stuff gives off the sewer gas. The part where it becomes dangerous is when that sewer gas accumulates, and it accumulates a confined space. So if we think about a sewer, by definition, it is a confined space. So it's not something that's continuously designed for human occupancy. It's got limited egress and access, and it's just some place that's enclosed that can really trap something. So most of the time, if we're talking about our meters, our range is relatively low, 0 to 100 parts per million on the Ray products, and then I looked up MSA, it's 0 to 200. So a little bit more. It gives you a little bit more capability, but I wouldn't even know that unless I looked at the manual, like we talked about, right? Resolution, same as some of the other ones, is 0.1 parts per million. So I think what are some of the calls that you can think of that this could be an issue?
Ducks in a sewer drain, dogs down the sewer drain, cats. So that's one of those things, like, we never really think about it because it's just a public assistance call, like, hey, there's ducks down a sewer drain. We get them quite a bit out here in the West County area. But take that step ahead. And we've had calls here that usually it's one person that stops and is like, hey, like, if we go into confined space entry, what's the first thing we do on confined space? We drop a meter down there to see what it is. Kind of consider the same thing like we are if we're going in to get ducks or anything, like we're making an entry into a confined space.
Absolutely.
If it's just the sewer drain on the side of the road, practice it. If anything, like it's getting these meters off, practice it, drop it down in there, and just go through the steps. So then it's that natural reaction when you do run this confined space. It should just be the next step of, hey, this has to go in the hole because we practice it on all these nonsense calls. It's just how we perform. But it's one of those too. It could save somebody's life. Like those ducks are down in there and you drop that meter down in there and get these readings or see what your oxygen displacement is and everything could make a difference. So that's one of those things. Just get in the habit of, even though it's something minute call of getting some ducks out of a sewer drain or a dog or a cat that's down there, but take the time and just measure it because that's what we have these things for. So.
Again, be vigilant and be aware of those dangers that could bite you.
And then also with this is the olfactory fatigue. So we were talking about that, like that's whenever you're not smelling it anymore. So that can be pretty dangerous. And you still have your meters will always show you what you have going on, even though you're not sensing it anymore.
Exactly. So if you had a reading of 95 parts per million, but all of a sudden you stop smelling the H2S, your body's telling you, oh, well, I think we're fine now because I can't smell it anymore. That's not true. The cells in your nose, for lack of a better term, they get tired and they don't smell it anymore because they're so overloaded, so you don't smell it anymore. So you're actually in danger, but you don't know.
Not a good thing. VOC. So this is one interesting too that I get a lot of questions at Metro West when we start diving into understanding what our monitors are showing us. So the easiest way this was put to me was there is stuff in the air that shouldn't be there. So your PID won't tell you exactly what chemical it is, what it is you're looking for, but it's screaming at you and telling you, hey, there's something here that doesn't belong. Is the easiest way to remember what this is there's something there that should not be there, and then you have to start figuring out from there and go through and start trying to, there's several ways we'll discuss on what you can break this down to hopefully figure out what it is that you're looking at.
Yeah,
so.
Absolutely. So we're talking about a PID, and that's called a photoionization detector. And basically what it is it's a lamp inside of your machine. It's very small, and it applies a current and ionizes the air that's coming in. So if we have some substance in the air that passes the light of this lamp and this energy, it breaks it apart so the other side of the sensor can see it. And then as soon as it exits, it goes right back together. But that reading that it senses is going to give you the number right here on your VOC. Now, when we talk about PIDs, most people, and it's very common to have a PID lamp that's 10.6 electron volts power. So if it's more than, there's one that's more than that and less than that, but the one that's more than that, it's a lot more expensive. It doesn't last that long, but 10.6 is basically the industry standard if we're talking about lamp power. And it will see anything with an ionization potential of 10.6 or below. So where we find that, especially when we're talking about VOCs, is we look at the NIOSH pocket guide, and we can see that under the IP of the chemical. And I believe that's under chemical characteristics of each substance that we're looking at. Another thing that's really important, talking about the VOCs and the PID lamp, is, again, we talked about correction factors with the LEL. That is equally important with your VOCs because those range and vary depending on manufacturer. And even with Ray products, the bigger lamp and the smaller lamp have a lot different correction factors for the same chemical.
Okay.
So that's something you should probably know, and we all know that because we read our
going back to reading your manual and knowing what your meter does.
Exactly.
So knowing these, that's another good point Nick brought up with finding this stuff in the NIOSH pocket guide. So when you look at like your ERG or your NIOSH guide, so your ERG more or less tells you like, hey, this is the problem that you have, and kind of some quick evacuation type issues. Your NIOSH guide is really going to dive in and tell you what you're looking at and what you really need to be concerned of and what your true problems and potentials are. With IDLH, if you know your chemicals, you can break down and figure out what can be seen with our PID, and break those chemicals down. So that's the true, even for a first new company officer showing up and being able to make some good educated decisions on what you have going on. And really when I look at my meters, it's going to help you really break down what am I looking at and what am I seeing just by looking at this pocket NIOSH guide if I know the chemical that I'm going into and investigating. So pretty important to really, once again, like know your meters, know what you're looking at, and then breaking some of these other books out and having an understanding of where I need to find this information at in these books. So, because that would make a big difference if I do know the chemical I'm going into, to be able to say, hey, this is exactly what I'm looking at and what my correction factors and everything need to be.
Yeah.
So,
and like you said, break these books out on a boring Friday morning. You don't have anything planned. You're the captain or you're the guy in charge of training, whatever.
Yeah.
Get these books out, because the fresher you are at the firehouse, the fresher you're going to be on the scene.
Yeah.
So, I know exactly where to look for the IP. I know exactly where to look for the UEL and the different data that can give you in the NIOSH pocket guide.
So quick, easy kitchen table training, kind of like watching us right now.
Yeah.
Some special considerations as we do this. We've talked about our equipment specs, like reading the manuals, knowing exactly what your meters are going to do, what you're going to expect from it, and how it's going to warm up and everything like that with the equipment specs. So what else we got on?
So yeah, just like Kyle said, every instrument is a little bit different. Like I said, you could have varying things. Even with Ray, like I said, there's a lot of different things. You think it's the same with the PID lamp, it's 10.6, but the one model is a lot different than the other.
Yeah.
Correction factors we talked about. So that's going to be, if it's not in your manual, you can look up a technical note like I talked about before, and that should be in there. Probably find that on the website, or if you ask your sales rep, he might know as well, or he or she, you know.
Cross sensitivities, I think we talked about that quite a bit, just really kind of knowing what's some, give you some false readings or give you something else, like, hey, if I'm looking for CO, I might not have CO, but I might have something else going on.
Exactly.
So I've had that on a few apartment complex calls. that we've showed up and there's been nothing gas, but like I said, that CO alarm's going off for something there, and you just have to go around and really dive in and try to figure it out. So another good thing, like to go back to the CO stuff, is understanding also like how your CO, like the residential CO monitors are built and when they actually go off. So there's certain readings and the manufacturers are different, and that's something worth looking into. Of it at certain readings, they're built that they don't alarm for several hours. So that's kind of set by OSHA and everything, I believe. So that it goes through of like, hey, it might not go off for 8 hours later that it's only been at this much parts per million in the house. So that's something else to really understand. I've had those calls where people have been baking all day long. You know, it's around Christmas time, holidays right now. And 5 or 6 hours later is when their CO alarm's going off. And it's like, and you try to figure out like, well, I've been baking pies all day long. Okay, well, that's going to help me guide down to, hey, it might be something with your oven going on, and it's just taking that long for the CO detector in your house to reach that proper parts per million. So that's something else just worth looking into whenever we dive into your CO calls and everything like that to help you trace down to what you have going on. Our attachments, those are big. So most of I know the Ray products, they come with the long wands and the tubing and all that stuff. MSA, I'm sure they have the same stuff. But that's something too, just remember when I'm using attachments on there, that's going to take a little bit longer for that gas to get into that meter and that pump to get that stuff up there for you to actually get your readings and everything. So as we go through, I can't just like dump this down here and be like, oh, I got nothing, and pull it back out. So it's going to take some extra time. So once again, just know by playing with these meters and getting them out of how long that's going to take. So if I go and I put something down in a sewer, I need to know how long it's going to take for those readings to come back up.
Absolutely. And something else about that too, try and keep the probe, especially if you're using an attachment, out of liquids, because we've had it before where somebody accidentally put it in liquid and then that sucks it up and that thing's out of service until we get it cleaned.
I can imagine.
And they're hard to clean, I'll tell you.
And you probably ruin your sensor, and those things are not cheap.
Potentially,
Tell us about some bump testing and calibration.
So we're talking about bump testing. So technically, if we're speaking on OSHA and regulations, you're supposed to bump test your 4-gas meter or whatever monitor you're working with before you use it, just to verify that it is working correctly and it's seeing what it should see. Bump testing is what's called a qualitative measurement. So what that means is basically it's a yes or a no. It's not really accurate. We're not talking about numbers at that point in simple terms, right? If we're talking about calibration, so that we've actually made the sensor accurate based on a known gas. So if we put it if we use our CalGas, I think you guys maybe have the AutoRay 2 system. So that's a known gas, and it will actually move or program the sensor to say, okay, well, we're a little bit off. We have some sensor drift, but we're going to move it over to where it's seeing the accurate amount of gas. So calibration typically depends on the manufacturer again, but I believe with Ray it's once a month. But bump testing, like I said, if you're going by the book, says before each use. Now, I know that's kind of tough sometimes, especially being on a fire truck and using that's not always practical. But as long as I believe if we're using the calibration, we're doing that on a regular basis, we'll be in good shape for that.
Just all other stuff to think about. Going on into our sampling. This is where we walk into the house, walk into the building, whatever the call is. Where am I holding this monitor? So if I walk in and keep the meter right here in front of my face and just kind of quickly walk through the building, I'm not going to get accurate readings at all. So this goes into just knowing a little bit of what am I looking for? What was I called there for? Is it CO, natural gas? Do they smell natural gas? Different things like that. Think about like where I'm going to hold this monitor. Am I going to put it down low, at my chest, up high? And as I'm walking through the house, walking through my building, out in the open area, like just taking the time to understand like what these different gases and chemicals are doing and where their vapors are going to be and stuff like that. Because if I just walk in, hold it here, I could be missing everything down at my feet. I could be missing everything that's up high. So just really having that understanding of what am I looking for? Where is these vapors? Where are these gases going? That's going to make a big difference as I walk through.
And like you said, being vigilant and being nice and precise and methodical about how you take your measurements and how you're doing your sampling really makes a difference. Because let's say we have gasoline, again, we had a spill. You're not going to find the vapors unless you're down almost to the ground. Right? You're not going to find them up here. But if you do find something up here, that should be a clue that you got something else going on. But if we're not walking through, doing high, medium, low, walking a little bit more, and doing that same process throughout the whole entire house, then you're going to miss a lot of clues, because we're playing detective at this point.
Yeah.
When it comes to hazmat.
Yeah.
Something else I want to hit: as soon as you get to a building that has a possible compound or some kind of chemical in it, as soon as you hit the door, you can actually sample around the door, give it a crack, and see if you can find anything around the door before you completely enter that atmosphere. It could be something like CO or whatever it is. So crack the door, go around the crack and see if you can find anything.
Before you even put yourself in that position.
Exactly. So you might find some clues there.
Yeah. So just go slow, methodical as we're going through this stuff. And then, like we mentioned earlier, when I'm going into these buildings, I might be on a CO alarm going off, but I'm going to take my time, go through every level, like Nick said, as I walk a little bit more, stop and go again. But look at each thing. I need to pay attention to what my oxygen's doing. If my oxygen drops that 1%, I've got something significant going on. If it drops from just 20.9 to 20.8, that's still 5,000 parts of something else in that building other than oxygen. Watch what my VOCs are doing. If I get into somewhere and I start getting something VOC, it could be a low number, but that's still that meter showing there's something else in the air that doesn't belong. So just because I run call, hey, I've got an odor of natural gas, or I've got a CO reading, I need to be methodical, go through and check and do my due diligence and check everything and pay attention to the small things on these meters. Another thing, keep in mind, like we talked before about the whole Phoenix thing with the CO2 readings. That's something else, keep in mind, like you're on some of these calls at these gas stations and stuff like that. Like I might not have a CO2 sensor on my meter, but is there something else that I'm going to see on here that I might see a change on this meter that...
Yeah, you could have oxygen displacement.
Yeah. So that simple one, if I walk in and just look at this, like, hey, that's showing me I have something different in the air displacing that oxygen that I need to worry about or try to figure out what's going on. So these things are very important, just kind of knowing how they work, what I'm looking for, and as I'm going through all that. So kind of the last big thing here that we get all the time is, when do I turn this thing on? A lot of us always do it because they take time to warm up. So especially the Ray products that are out there. I know ours is, there's a lot of times I'll get off the truck, be talking to the homeowner, and the back step's still sitting there like, no, like it's, give me a minute, we're still warming up, or then they had to do a fresh air calibration. So a lot of times we turn them on in the truck on the way there. So something just be cognizant of, if you did have that fire, your gear's in there, gear might still be off gassing, and now I'm turning this thing on inside the cab of the truck, and it's trying to do a fresh air calibration while your gear's off gassing. So that's just something else to keep in mind. If you have that situation, it might be worth just waiting till you get on the call and actually turning this thing on in the front yard and letting it get a true fresh air calibration, so I'm not riding down the road.
Right.
So,
and that's important because these sensors need time to warm up. They need time to do, like you said, the fresh air cal, because if you don't do that right, all your readings after that are going to be inaccurate, possibly. So very important to do that stuff. And I know it sucks, but you just got to be patient with it and let it do its thing.
Yeah. So. Dive into some scenarios. We put some scenarios in this company training. Let's kind of bring all this together. So I know, Nick, you had a great one for CO calls.
Yeah, this is one that I ran a couple months ago. So it was a multiple dwelling, multiple story apartment building. I believe it was 4 stories. And Kyle, you can pull it up on your phone and correct me if I'm wrong if I get these details right. But we got a call from the lady on the first floor that said there's a chemical odor. She smells something weird. She doesn't know what it is, but there wasn't any definite clues for it to be a natural gas call, or obviously you can't smell CO, but something that related to CO or anything else. So we get there. We came off. We were vigilant, as we always should be. Came off with our air packs on, full gear. And we were the second due truck, and we came off with our 4-gas started up, 2 different ones, so we could back up our readings and make sure we have accurate readings on that. So came off, and as soon as we hit the door on the first floor, we started to get some low-level readings. I think I put maybe around 50 or below. Made interface with the first due truck captain, and he said, hey, can you go check the other floors to see what we got? I'm not real sure what's going on yet. So we did that, and as we worked our way up towards the 3rd floor, we started getting increased readings. So increased on the 2nd floor, and then we get to the 3rd floor, and we got up to, I believe it was around 200 or less parts per million of CO. So went up to the 4th floor, they decreased a little bit, so our problem was on the 3rd floor. So come to find out, we started going door to door, checking the apartments, checking the furnace. There's a couple of furnace rooms in this specific apartment building, but we actually narrowed it down to one apartment, and we knocked on the door, said, hey, is everything okay? And our readings went up as soon as we opened the door on that. So we made entry, and come to find out, this older couple had left a silicone baking mat on the inside of the stove, and they had it on self-clean. And as we know, on self-clean, it gets super hot, like around 500 degrees, I believe. And it burned that up, and it filled the whole apartment building with smoke, or with CO, because I guess it distributed through the HVAC system. So just something that's, like we talked about before, consider alternative sources when we're talking about CO. It might not always be the furnace. It might not always be the water heater. It could be something as simple as, oh, I left some stuff in the oven, some plastic stuff, and it actually charred, but it actually put CO throughout the whole building. So that was my scenario. It was kind of interesting, but we had to kind of play detective and use our readings to narrow down the location of the source. So I know you actually had scenario 2, so if you want to go over that real quick.
So another one that we ran, just kind of off the wall, kind of an oddball one, is we ran for is after storms came through all day and kind of heavy rains throughout the day and stuff like that. Got called for odor in a house, and showed up, and the homeowner meets us at the house and is just like, hey, I've got this odor throughout the entire house. Just a pungent, nasty smell. Not sure what it is. Don't know what's going on, but it's throughout the entire house. So I immediately start thinking, hey, HVAC system. If it's equal throughout the entire house, there's something pumping it through the entire house.
Right. Mm-hmm.
So walk in the door, and we have our meters with us. Start getting some VOC readings, nothing huge. But you can smell, like it's a pretty strong, just nasty odor. And kind of as we travel the house, it's equally throughout. So we go down, shut off the HVAC system, and it's a finished basement. And when we get down to where the HVAC system is in the finished basement, it is a strong, like bring tear to your eyes type of just pungent, nasty odor. Mm-hmm. Shut off the HVAC system, start ventilating the house. And as we snoop around a little bit more, we notice like around the sump pump, we start getting higher readings. Look in the sump pump, and you see like this green film in there. Kind of ask the guy right away, like, hey, like, did you dump something in here? Like, what is this going on? If the neighborhood that we were in, like, trust me, this guy does not cut his own grass or have chemicals. Like, he has people for that.
Yeah.
So go through and more or less find out, like, his sump pump was running from all the heavy rain and burnt up and actually cracked the housing on the sump pump and leaked all the oils out, and it burnt up all the oils in there. So that was one of those, like,
interesting.
Deeper we got into there, the higher VOC readings we have, and it's like really just playing the detective, trying to figure out, like, okay, why are we getting these readings? So obviously it's going through the house because it's going through the HVAC system.
Right.
Shut that off, ventilated, and we tracked it down to, like, okay, this is coming from this room in the finished basement, and then just trying to figure out, like, what it was, where it was coming from. At one point, like, MSD was involved because they were thinking, like, hey, there might be something in the drains and stuff like that. So just really going in and trying to figure this thing out. But that was, for me, that was earlier on in my career, and just kind of one of those oddball, like, stick with you for the rest of your career type of deal. Like, hey, if I run this weird odor, we need to start looking at these oddball things that might be seeing these.
Yeah, and oddly enough, I've had that exact same call, and we had a discussion before that call, and I was able to remember that, and we went straight to the problem. So
that's why it's so important to share these calls and stuff. Like, you'll find out about all kinds of different things. So awesome. Well, thank you everybody for your time. Hopefully you guys get something out of this quick little company training over meters. As always, any questions or anything, get a hold of your chiefs, and they can get a hold of me and Nick or anybody else that can hopefully answer and help people out. Yeah.
So real quick, just make sure you check on the end of this video. I think we're going to post a link to the quiz. So if you want Hazmat CEUs, if you're a technician or you just want to dive a little deeper, take the quiz and we can register you for some CEUs. And then on Career Cert, we will get a separate video on CO. It's going to be this quarter's subject, so you can get EMS CEUs. So do that. Also hit up our podcast, Make Hazmat Great Again, for some great discussion and great content there. So appreciate your time, and thank you, Kyle.
Yep, thank you.